Hey guys, and welcome back to another Django website tutorial episode. In this episode, we're going to be talking about how to deploy the application with Kubernetes, and we're going to test it using our local Docker setup. So let's get started. In one of the last episodes, we installed Docker so that we could test our application locally, kind of mimicking the way that it will be running in the cluster. It's not exactly the same though, because we were using a Docker compose file, which creates several Docker containers which run on your local machine. In order to get this website running in a cluster, we're going to need to use Kubernetes, and we'll have to create some Kubernetes resource configs in order to make that happen. So Docker Desktop has this really cool feature where you can enable Kubernetes, which runs locally on your machine inside of a Docker image. So you can enable that by going into the Docker preferences, clicking on Kubernetes, and then just enable the Kubernetes cluster. Now, while that's spinning up, one thing that you will need to install locally is something called kubectl. And this is basically just a command line tool that you can use to inspect pods that are running in a Kubernetes cluster. So if you go to the Kubernetes website and search for kubectl, you should find an install link. There's also one more dependency that we'll need to install while that's spinning up. This is called Helm, and Helm is basically a way to template some Kubernetes resource configurations that we'll be creating for this tutorial. You'll want to use Helm because maybe different environments have different variables that you'll need to change, like maybe you'll have different secrets, and it also manages the deployment and updating of resources in your Kubernetes config. So if you go to helm.sh/docs/intro/install, it'll tell you exactly how to install Helm. Okay, so now our Kubernetes cluster is running, and if we go into the Docker icon in our taskbar, we can take a look at the Kubernetes cluster. I was using Minikube earlier for another project, so that's selected as a context, but you'll need to switch over to Docker Desktop as the context. And now you should be able to connect to your local Minikube cluster. Once you have your application deployed in production and serving real traffic, you can also add context for other clusters which are not running on your local machine. And they'll be available here through this Kubernetes context manager. So it's easy to swap between the different clusters if you want. Let's open up the terminal and type kubectl get pod. And now you can see that there are no resources in our namespace, and that's expected. So Kubernetes has this concept of namespaces, and namespaces are basically like groups of resources you can put permissions on. So if you have multiple people using a cluster, you can assign different permissions to different namespaces for those people so they don't botch other people's resource configurations. By default, we're just going to use the default namespace. Since our application doesn't have multiple contributors, it should be fine. Kubernetes also has this concept of a pod, and a pod is it's sort of like a virtual machine. It's a virtual instance of a container that's running in your cluster. Usually for basic applications, you might just have one pod running, but if you wanted to, and say you're running a site like google.com, you'll definitely have a lot of traffic and you'll need a lot of different containers serving your application because there's just so much traffic it would overwhelm one pod. So you could have thousands of pods if you want serving the same application. So it's basically just a way to scale up your application so that you can serve your application to more traffic. I think a good starting place is usually 2 pods. It's not very expensive, and if one pod goes down, you'll have another one to back it up. So now let's get started and create some of our Kubernetes resource definitions so that we can spin up some pods in our cluster. So now I'm going to create a directory called Helm. And now we're inside the Helm directory and there's nothing there. And there's this really nice command that you can use to create a new Helm chart. A Helm chart is basically like a collection of Kubernetes resources that's composable, so you can use it in other charts if you want as a subchart. And I'll show you exactly what that means in a little bit when we'll use a subchart for our Postgres instance. So if you just type Helm create and then the name of your chart, let's just call this Django website. You'll now see that we have a Django website folder inside of here. And inside of our Django website tutorial, we have a templates folder, a values YAML file, a charts folder, and a charts YAML file. So let's go into our IDE and take a look at this. So if we go into the charts YAML file, this is kind of like the configuration, the main configuration file for your chart. The values file has values that you can change depending on where you want to deploy the application or what configurations you want to have. So you'll notice that there's a bunch of stuff that was generated for us by the Helm configuration. There's also this templates folder, which has a bunch of different YAML files. And I'll just quickly scroll through these so that you can see them and explain what they are. So the deployment is basically like a configuration for how you want to deploy your application. It has things like the number of replicas or pods that you want to deploy with. There's also some configurations for the Docker containers that you want to spin up and run within these pods. You can also do things like configure liveness and readiness probes to make sure that your application is running properly. If it's not, then Kubernetes will automatically restart the application for you. We also have something here to define the image for us. And then there's some other things like the resources that we want to use. So you can specify the number of CPUs that you want or the amount of memory that you want. There's another file called HPA. This is the horizontal pod auto scaling. So if you enable this, you can scale your pods depending on the amount of traffic that you have, or the CPU utilization that your pod's having, or the amount of memory that your pod is using. This is not enabled by default because if you look at this value and compare it to what's in the values file, it's set to false, so it's not enabled. But if you wanted to, you could enable this. The ingress defines the DNS routing rules for your service. So if we go back into the values and look at ingress, you can see that if you wanted to, you could define a host name. There's a service YAML, which defines a Kubernetes service name that you can hit within the cluster. So if you have several different services running in your cluster, they can reference each other by this service name. So like if service A makes a call to service B, it could reference it through the service name that's defined by the Kubernetes service. And then there's also service account, which gives your pods permissions to do things within the cluster. You'll notice that some of these resource definitions, like the ingress.yaml, have a lot of these curly brace tags with various things in them. You know, you can do things like create variables, you can inject values, you can even use templates in here as well. There's this helpers.tpl file, which allows you to define a bunch of different like templates that you can inject into these YAML files as well. I think we probably won't go into these too much, but you can read about them on the Helm documentation. All right, so now let's go back into our values.yaml file and take a look at line 7. So you see that it already has an image specified for our service. And as it stands right now, we can just deploy this sample Helm chart. It will deploy with a Nginx image. So let's just go ahead and do that just to see how it works. So I'm going to go back into my terminal. First, you're going to want to make sure you're in the root folder of your project. Now we need to type the command Helm Upgrade. You could also use install, but it would only work for the first time. So I usually use upgrade and I pass the install flag, which will install if the chart's not available. Let's give a name for this chart. So let's call it Django tutorial. And all of the resources that are created will be prefixed with this name. And then let's give it a path to the Helm folder. So it'd be Helm/Django website and hit enter. Okay, so now it says it's deployed and there's some helpful notes that are generated here as well. So if we do that same command that we did earlier, kubectl get pod, you can now see that we have the pod running. It's not quite ready yet, so we could just refresh this a couple times and then there we go. It looks like it's running. It mentioned here that you can also run a command to port forward to use the application. Let's just go ahead and do that. We can type the command kubectl port forward and then we give it a pod name. And we map a local port to the port running on the pod, which I believe it was 80, but let me just double check that. So you can go into the deployment and then look at the port that is exposed for the container, which in fact is 80. So let's map that to 80. And so now if we go to localhost 8080, we can see that it handled a connection here. And also we can see the Nginx welcome page. Okay, so let's kill this. You can do that with Control-C. And let's work on getting this Helm chart that we created, deploying our image that we're using for our application. So you can look at your local images using the Docker image ls command. And looks like I don't have my image built locally because I had to upgrade my Docker engine here, but we could easily build that using the make command that we created in one of the previous episodes. So let's go into the make file and take a look at that. Let's just go ahead and do the build prod. All right, so now if we do a Docker images, we should see that I now have that image built here. And now we just need to tag this so that we can upload it to a Docker Hub repo. I already have a Docker Hub repo. Usually what you want to do for this is create a private repo. So I have a private repo here that I created a while ago. And if you create an account on Docker Hub, they give you one free private repo. But I really recommend this because once you create a cluster, you'll need to pull your image into the cluster, and it's a lot easier with this Docker Hub repo. So I called mine Hacker Shack website tutorial. You won't be able to access this because, again, it's private, but I'll show you exactly how to push an image up. And it actually tells you right here. So if you run this command, you can go ahead and push up your image. But we do need a tag name for this. Let's go ahead and tag the latest image with a version that I can pull in. So I have test v001, v002. Let's go ahead and create a new one called v003. Okay, so I can do that by running docker tag, specify a source image name. Let's call it this latest. And then we also need to specify the target image name. This would be atainter/Hackershack website tutorial, and we want this version to be v0.0.3. Just hit enter. Now, if you do another Docker images, you can see I have this atainter website tutorial. And so now we can just push this up to the repo using that push command that we just saw. Let's do docker push atainter/image name, paste this, and then give it a tag, which would be v003, because this is the image we have locally, which should match what we push up to the Docker Hub repo. So I'll just go ahead and do that. You'll notice that I was denied because it says requested access to the resource is denied. So I'll need to log in with Docker, and you can do that by just typing docker login. And it will ask you for your Docker Hub credentials. Okay, so now my login succeeded. And if I run that same command again, I should be able to push the image. While this is working, I should mention that if you're using Docker Desktop, you can actually reference the images that are running on your local machine from within the Kubernetes cluster. But just to show you how we should do this in production, this is why I'm using the private repo. Okay, so it says it just pushed. Let's take a look at the repo and refresh. Okay, and now you should see the v003. So now we'll have to do another step to make sure that our Docker Kubernetes cluster has the credentials to pull that image. There's a command that you'll need to run in order to create a secret within the Kubernetes cluster in order to make this happen. Before we do this, let's just make sure that we remove that prior release that we just created because we don't want some of the new resources conflicting with that. Run Helm delete and pass the name of the release that we created earlier, which was Django tutorial. And this will go through and remove all of the resources that we added for that release. This is especially nice because if you have like 50 different resources as part of your chart, it will just go ahead and remove all of those for you. The command that we're going to run to create a Docker Hub Credential secret will be using the kubectl command. Create secret Docker registry, give it a name. Let's say red cred for regular credentials. Let's pass in the Docker server, which would be equal to the Docker Hub server. And you can find this online, but it's https://index.docker.io/v2. I'm going to add my actual login credentials off screen, but you would pass in a flag for Docker username, which would be your username. Pass a flag for Docker password, which would be your password. And then you would also have to pass in your Docker email, which would be your email that you signed up with. So I'll do this off screen and come back when I've added that. I've added my secret, and like pods, you can also view other resources on the cluster. So ingress, service counts, services, deployments, HPA, and secrets, which we just created. If I do kubectl get secret, I should be able to see the secret that I just created, which is this one right here. Now we'll need to tell our deployment to use this secret in order to authenticate with Docker. And you can do that pretty easily using something called the image pull secrets. So you notice that there's already a templated value right here that we can use. So if we go into the values file and then just go down to the image pull secrets, we can add a new value in the array, regcred, save that. Let's change the image to the image that we pushed up to our Docker Hub repo, which was atainter/hackershack website tutorial. The tag was v0.0.3. Then the last thing we'll need to do is make sure that our deployment is starting our service properly. So if we go back into the makefile, you'll notice that we don't have a command to start the server. So we do have one to run it in Docker Compose, but because we're not running in Docker Compose, we'll need to just run it normally. So let's go ahead and create a command called start server, and to run we'll just do python manage.py run server, and we'll do 0.0.0 and point it at port 80 because we're running 80 within that deployment. And then while we're here, let's just add a couple more things for pushing the image. So I've already done this off screen and I'll just copy it in. I'm going to create a couple variables for the tags that we're using for these images. You can override these variables when you use make. So if we wanted to change the version or something like that, we could do that. And I'm just going to add one more command here to push the image. We'll say the tag is latest, and then we'll tag it with a tag that we want to push up to the Docker Hub repo. And now we can use this to push a new version of the image if we want. Let's copy this command, go back into our deployment YAML, and add a new section inside of the container, which will be running our server. Let's call this command, create an array, push in the command to this array. So the command will be make start server when it starts running. Now, to make sure that this all looks good before we deploy it, let's just do a quick dry run. So let's just pull up that command that I did earlier, and let's add a couple more flags just so we can test this. So the dry run command will basically attempt to push the Helm release into the cluster, but it won't actually do it. It just outputs the generated YAML files with all the templated values filled out. I usually use dry run debug for this, and it looks like there was an error when we did that. I was doing the values wrong. So it specified an array, but it actually needs actual YAML that it will inject into the resource configuration here. And then I went ahead and ran that command again, and now we can see the output of the dry run here. So if you scroll down to the deployment kind, you can see that we have the command for make start server, and there's also this image pull secrets here as well. So I just added this new command to the makefile. And since it's not in the image that I built and pushed up, it means it won't be available on the pod to run. So we're going to have to push a new image. Let's do another make build prod. Okay. And now what we can do is use the make push command and then set the tag equal to 0.0.4. And now if we go back into our Docker Hub repo, you should see that new image. Let's go into our values file and update the tag to v4. The other thing that you want to do too is whenever you deploy a new application, you should bump your version so that it knows how to update the chart properly in Helm. So I'm just going to remove app version, bump the new version to 0.1.1, and then I will do the same command that I did earlier. So this should update the pod to use the new image, and you can actually see it's revision 2, so it just deployed a new version. Okay, and it looks like the new version is also failing, so let's see what's wrong with this one. So I just did some digging, and I think the other issue is I actually forgot to include the makefile and the Docker file. So let's just double check that that's in here. So since we're building from production, we didn't copy all the files like we did with the development image here. I'm just going to copy over the makefile as well, and we'll just copy that to ./makefile in the image. And then let's just build this one more time and push a new version. All right, and now we can see this pod running. There's 2 other pods that are running here as well. These are the ones that failed. They will get removed after this actually is running. So you'll see that this one's now terminating. Let's just get the pods again. Okay, you can see this is running. Everything looks good. And I think this is actually going to fail because there's a Django setting that we need to change to. So if you go into the deployment, you'll see that we have these liveness probes and they're making requests to the server. So these won't be allowed to make requests to the server unless we update the allowed host to say that anything can hit this. Let's go into the settings and change the allowed host so that anything can hit it. I will note that if you're doing anything that you care about security for, you won't want to set your allowed host to anything. You'll want to set it specifically to servers that are allowed to hit your server. But let's just set it to a wildcard for now just because it's easier to get working. So if we go into settings and then just change this to a star, that should work for us. And let's just double check that this is not running yet. Yeah, so it's starting up, but it's just not able to do the health checks properly, so it's not saying it's ready. And we can actually confirm this by doing back to the logs. Yeah, so this bad request, this is what I'm talking about. So we could add the IP to allowed host, but it's going to change if we go to a different cluster. So we'll have to see what that is once we're in our prod cluster. We'll have to do another make build and push another image because we've changed some code. Change this to 6. Now it's pushed. Let's do another Helm deploy. And I think because I'm doing this so often, I should probably create a make command for it. So let's go into our make file, copy this command, and let's just call this one Helm deploy. So now instead of doing this, we can do a make Helm deploy, and it should deploy the application. Okay, now here's our new pod. We'll have to wait a couple seconds for the health checks to start running. There we go, now it's running. So now let's do the same kubectl port forward command that we did earlier, just to double check this. Instead of passing in a pod name, you can also use a service. The service name is this. Let's just call it svc/Django website, Django tutorial, Django website. Then we can go to localhost 8080. And there we go. Looks like we have another problem. All of the CSS and JavaScript is not loading, which was why this looks like it was made in 1995. And if you right click and then do an inspect, if you're in Chrome, you can pull up all of the developer tools here. And if you click on the console, you'll see some errors. And it says that they're not found. Same thing in the network tab. You'll see these red things, means the resources are not found. And if we run this locally, we'll see that's all working. Problem is, there's another thing that I forgot in the Docker file when I created it. So I wasn't copying over the static folder, which has all of those scripts and everything in it. So we'll have to do that as well. You know, maybe let's just rearrange these things a little bit because, as I mentioned in the Docker video, these are all cached by layer, meaning you want the things that change the least happening first, just so your builds go faster. So let's put the make file before the source because it'll probably be updated less than the source. And then maybe the next thing would be the static file. Let's do one more make build and try this again. Now let's do a make push and let's bump this image one more time. I'll go into my values, set the new tag as 7, and then update the Helm chart as well. And then we can do a make Helm deploy, and it should update our app. kubectl get pod to look at the pods. And you can see this is now running. Let's do another port forward. Open up the browser, and let me refresh this guy. There we go. All the scripts are working. Now, this website is actually not functional yet because we're not connected to a database. So let's add a subchart to our Helm chart for Postgres so that we can spin up a database in Kubernetes. Okay, so to add a subchart for Postgres, let's click on the Django website tutorial and add a new file called requirements.yaml. And now let's add a couple things to this file. First, we'll add a key for dependencies. And we'll add a new dependency for Postgres. So I'm adding a chart for Postgres, which Bitnami has a bunch of great charts you can use, but this is what we're going to be using. It's called Postgres SQL. Let's just add a name for that right here. And then we have to specify a repository because this doesn't come from the default Helm repository. So this will be add Bitnami, and we'll have to use Helm to add the alias for this repository, which we'll do in just a second. I'm going to add a condition so that we can enable it through the values file or disable it if we want. Just call this Postgres SQL .enabled. And then we also have to specify a version. So if we go into the chart YAML and look at the version, you can see it's 10.4.4. So we'll just use the latest one, which is 10.4.4. And we need to make sure that we're in the right directory. Go to the Helm folder and then the Django website folder. And this will not work because we don't have the alias for Bitnami. Actually, I already added it, but if you want to add it, there's instructions on this page for the Bitnami subchart. So you can just run this command in your terminal and it will add an alias for that. So I already have it, so it says skipped. And now we can run the dep up. And I also caused an error because I quit out of it too early. So let me just remove all the old stuff. And now so now we have the charts installed. And now if you look at this charts folder, it's green because we added the Postgres chart here. So in order to use this, we're going to need to go into our values file and enable it. Let's go into the values, and at the bottom, we can add a new section for Postgres. And then let's just set enabled equals true. And now we'll need to configure the website so that I can connect to the database. But let's go into the settings and let's just look at our database settings real quick. I already had a couple different environment variables that I was using for the Postgres instance. So let's just copy these and go into our helpers and let's add a new section for the environment variables for this. So I'll comment these out. The Postgres chart creates a secret with some keys for the different environment variables that we're using. So it'll have host, DB, user, password. And so we can just take those secrets from the secret file. And again, that's a Kubernetes secret. And then we can use those to fill out the environment variables that will be used by the deployment. Let's create a new template here. And let's call this Django website.db.env. And let's end the template. And so these minuses basically just remove spaces. So I'm saying remove spaces after this and before the end block here. And so let's create some YAML for the environment variables. So this first one will be called Postgres host. It will have a value, which we haven't filled out yet. Let's copy this a few more times for all of the other environment variables. And there are 4 of them. So let's just change this to DB. Let's change this to user, and the last one to password. The host is going to be the service host. By default, it prepends the release name to Postgres SQL, and that's the name of the service that you can have as the host. And the Postgres chart does that automatically for you. So let's just go into our makefile and look at what our release name was. It was Django tutorial. So we can copy this and then go back into the helpers and paste this -Postgres SQL. So there are a bunch of settings in here that you can change. So one of the things that it sets is the service port, and that's set at 5432. So I'm just going to copy this and hard code it in my port. Actually, it looks like we're missing a port, but I think it was already set in the settings as 5432. Yeah, so we don't even need to change that because it's already hard coded here. So the username is set as well. So let's just search for the username. And there's this variable called Postgres SQL username. You can just go ahead and use this, which default is Postgres. And then one thing that you can set as well is the Postgres SQL database name. So by default, it's nil. Let's set it as something that we can use. By default, all of ours were empty strings, but let's just go ahead and set this as something more predictable here. So I'm going to change this to Postgres, just like the user. And I can reference this by just using the values. So if I go back into the helpers, I can say this would be the .values .postgres SQL .gres SQL database. And you know what? Let's just change the name of the username as well, just so we have it hard-coded from our values and it's more predictable as well. So we already know it's going to be Postgres, but let's just hard-code it to Postgres here as well. And we can go ahead and reference that same value from the helpers. Now, the last thing we'll need is the password, and the password is actually stored in a Kubernetes secret, which gets created by the Postgres chart when it's installed. And so you can reference that by referencing the secret name. So instead of value, you can use this value from keyword, and in the secret key ref, you can specify a name of a secret. So the name of the secret will be the same as the name of the service. And the key will be Postgres-password. I was using an older version of this, so let's just deploy it and then double check that this is actually the correct password, but we can easily do that by inspecting the secret. Okay, so now I can get rid of these lines here, and then let's inject these environment variables into our deployment. Okay, so if I go into the deployment, inside of the container, we can add another key, and this key is called the env. And then what we can do is just reference that template that we created in the last step. So we can say include, pass in context from the values file, which is what this period means. And then we need to indent a certain number of spaces. So it should be the same number as we're tabbed over. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can put 10 right here. And now we need to double check what our helper was called. Django website env, and let's just go ahead and paste that there. And now let's do a dry run just to double check that this is injecting the environment variables properly. So it's Helm Upgrade install dry run. And we're still in the Helm directory, so let's just cd out of that, and then we can run a dry run. And it looks like because I had this extra minus at the end, it was actually removing the spaces behind this block of text that I added in here. So it was bringing this line up to the previous line, which is not what we want. So you just got to be careful with those minuses to remove the spaces. So let's remove that and then try another dry run. And now we can see that there's a whole bunch more stuff in here because it also includes all of the Postgres SQL resources as well. This one is the one for our website. You can see now that it has the database, user, Postgres password. There's also one down here for the deployment for the Postgres instance, and we should just double check to make sure that this stuff matches up with the stuff that we specified for our Postgres instance. So it looks like it is right here, Postgres, and it's using the same key for the password. So now we can go ahead and bump the version on the chart. And now let's just go ahead and upgrade this without the dry run command. It does look like there's an error here, so let's just double check to see what's going on with this. Okay, so it couldn't find the key Postgres password, so let's just double check the output to make sure it was the same thing. Okay, so I did miss the SQL at the end of Postgres. So let's just go back into our helpers and let's add SQL to the key. We can bump the version one more time and let's try redeploying. You can see that our pod is running, and if we inspect logs, these are all the health checks, but we can see now that it's running. But the only problem is we still don't have the migrations applied. So we're going to need to create a container which will apply the migrations before the service starts up. We can do that with something called an Init Container. Probably don't want to run migrations if you're running more than one pod because they would run on every single pod. But init containers are a way to run something before your main container starts. So it's just another key like the containers. It's the same level actually. It's camel case init containers. Now we can create a new one with the name, let's just call it migrations. Inside of here, we're going to need to use the same environment variables as our normal container. So we can go ahead and put that in here. And a lot of this stuff is going to be the same. We'll also need to copy the image pull policy, and command from the normal container as well. And then let's just paste it right up here. The only other thing we'll have to do is change the command because we want to run migrations. So let's go into the makefile and let's add a new command for migrate. All right, so all we have to do here is type python manage.py migrate. This should apply all of the migrations, and we already have credentials to connect to the database, so it should know which database to connect to. So let's go back into our deployment and just change this to migrate. Okay, and then we'll have to build a new image because I just added a new makefile command. Our image is currently on 007, so let's just bump this to 008. Then we can go into our chart and bump the version one more time. Now let's do a make helm deploy. Okay, so after some digging, I did find that there's some, I don't know if it's like a bug with Docker Desktop or something, but if you don't specify a password for your Postgres Helm chart, it creates a secret. It's supposed to persist that secret every time you upgrade, but for some reason with Docker Desktop, it's not working. So I did end up hard coding a password in here. You should be able to remove this if you deploy to a normal Kubernetes cluster, because I think it's because the persistent volume claim is not working properly. But I just hard coded the password here, and then in my helpers, I just added some branching logic that says if that Postgres password is set, use the value of that instead of the secret. Otherwise, just use the value from the secret. You can test your own stuff by removing that. And yeah, so now if we open up our terminal, we can get pods and we can see that it's running. And if we look at the logs, we can see that those migration warnings are now gone because we've migrated the database. Okay, so that's it. That's how to deploy your application in Kubernetes and connect to it through port forwarding. Just to recap, we created a Helm chart, we added an image to Docker Hub and set up credentials so that we could pull it into our Kubernetes cluster. We also added a subchart for Postgres and pulled it in, deployed it, and set up credentials so that we could connect and run migrations on it. If you like this tutorial, make sure to subscribe to keep up to date with all of our other projects and tutorials. We also have a Patreon page where you can find all of the code for this tutorial. It's $5 a month and it really helps the channel out. So yeah, thanks again, and I'll see you next time.